All right, in this video, we are going to work through the following example. It says verify the identity, and the equation that we have is 1 over cosecant x minus sine x equals secant x times tangent x. All right, so and we want to verify that this is actually an identity. So we're going to pick one side and start working on that side and see if we can use algebra and the other trigonometric identities to transform that side that we choose into the other side. So normally you would want to start on the more complicated side. To me, that's this side over here, the left-hand side. And so what I want to do here is, first off, I am going to write cosecant x as in terms of sine x. And we know that cosecant x is 1 over the sine x. So that'd be 1 over sine x. And then minus sine x. Okay, so what that does is it creates a complex fraction. That's a fraction that has a fraction in its numerator or denominator. You can see we have some fractions in the denominator here. So what we want to do is go ahead and combine these two fractions in the denominator of the big fraction. And remember, you can always write that as a, always write this as a fraction by putting it over 1. Okay, so I want to combine these two fractions and then I'm going to do the division. So looking at these two fractions, they don't have a common denominator, so I need to get a common denominator. Here we only have two fractions, and one of the denominators is 1, right? So that means that, and this one's sine x, so that means sine x is going to be the LCD here. All right, next up, what I would do is look at each one of those fractions and ask myself, hey, what would I multiply this denominator by to get the LCD? And with the first fraction, it has the LCD already, so the answer to that question would be 1. So there's no point in changing it, right? This has the LCD. When I look at the other fraction, right, and say, hey, what would I multiply this denominator by to get the LCD? It's going to be sine x, right? So I would multiply the denominator by sine x. Then I would also need to multiply the numerator by sine x as well, so that everything is balanced out. Next up, go ahead and carry out those multiplications. So there's nothing to do with this fraction over here, but rewrite it. Here I can multiply these two fractions. Sine x times sine x is sine squared x. 1 times sine x is sine x. All right, so now these two fractions have, in the denominator of the big fraction, have a common denominator. Then I can combine them into a single fraction. So that's 1 minus sine squared x, and that's over sine x, okay? Because that's how you combine two fractions. Or subtract two fractions, subtract the numerators, 1 minus sine squared x, and keep it over the common denominator, sine x. Okay, so we combined the fractions in the bottom to be one big fraction. And the reason why we did that is so now we can simplify this complex fraction. Here I have the number 1 being divided by this fraction, right? So the way that you divide fractions is you're going to invert the bottom one, take the reciprocal and change it to multiplication, right? So 1 divided by this fraction is the same as 1 times the reciprocal of this fraction, which is sine x over 1 minus sine squared x. Okay? And of course, that is just going to be sine x over 1 minus sine squared x. Because anything times 1 is itself, right? Okay, so we got rid of the complex fraction, and here's what we've got. It still doesn't look a whole lot like what we've got here, okay? We want a secant and a tangent. Well, where's that going to come from? Well, the next thing to do here would be to take a look at that expression in the bottom. There's not much I can do with sine x by itself, but here I have 1 minus sine squared. If I look at these identities, right, if I subtract cosine squared from both sides here, I wind up with the fact that sine squared equals 1 minus cosine squared. So I'm rearranging this identity that I already know to be true. I know that 100%, right, that this is an identity. Well, that means it's also true that sine squared equals 1 minus cosine squared. So I can replace this 1 minus sine squared by cosine squared. All right, so far so good. Now what I need to do is to try and get a secant and a tangent in there somewhere, okay? And so I can do that. If you look, I have a sine over cosine that's kind of hidden in there. So if I pull that apart a little bit, cosine squared is just cosine x times cosine x, right? So you can see I have sine x over cosine x. And then I'm going to pull it apart even more. So I'm going to write this as 1 over cosine x and write this as sine x over cosine x, like so. And now you may say, well, wait a second, where did you get that from? But if you think about it, right, how do I multiply two fractions, right? If you multiply two fractions by multiplying the top parts and then multiplying the bottom, right? Multiply the numerators, multiply the denominators. So if I start at this and multiply 1 times sine x, that gives me sine x. Cosine x times cosine x, that gives me cosine x times cosine x, or cosine squared. So you can see that these are equal to each other. And the reason why I pulled it apart is so I was trying to match it up with this, right? I knew that I wanted tan over there on the right, so I could pull off this cosine, this sine and this cosine, and then everything else over here. And you can see that's exactly what I want to do in this problem, right? Because 1 over cosine x is secant x, right, by the reciprocal identities. And then sine x over cosine x is tan x by the quotient identities. All right, so you can see that is exactly what I have over here on the right-hand side. And so therefore we have established that this is indeed an identity.